What's good, Year 11 VCAL Numeracy class, Mr. Herman here, and this lesson will be looking at log 5 stem and leaf displays. The actual log sheet for this, log 5 stem and leaf, you only need to do question 1 and question 2. So when data is grouped, so remember data is just collected information. When this data is grouped and displayed as a column graph or histogram, the original individual scores may be lost. So what does that mean? You know, when we create a rough histogram that looks like this, and you've got your little bars that go up, and they might tail down, and they've got some numbers on the bottom, and they've got a frequency on the side. Even though we can see that it shows us how many numbers belong into each of these categories, say for instance this could be 10 to 20 to 30 to 40, etc. We know how many numbers lie within this category. So we get a data set, and between 30 and 40 we know that there are 5 numbers for this hypothetical example, okay? But what we don't know, what are those numbers? We know that 5 numbers lie within the interval of 30 to 40, but what are those numbers? What are the numbers? Maybe there were heaps of 31s, maybe there were 5 31s, maybe there was a 32, 34, 36. We don't know. And this is the drawback to histograms. Luckily, we have stem and leaf plots. So to avoid this loss of data, a stem and leaf plot is often drawn instead of a histogram. The stem and leaf plot uses all the original data, and the leaves are placed in ascending order. Ascending just meaning small to large. Okay. Smallest number to largest number. So stem and leaf plot is shown for the data from example 36C-2. Which is a weight in kilograms. So I'll quickly pop that up. And let me just get the textbook. So 36-2. 36-2. Here we go. So this information here. Alright, so this group data. 26 students in a maths class got the following weights. A bit of random set of data, to be honest, specifically weights of them. Don't want to body shame or anything, but let's just take it for face value. These are the different weights here. So when we put this information into a stem and leaf plot, the lowest number in here from that list was 59. So the lowest is 59, and how I knew it was 59 was because this stem indicates numbers starting with a 5, and this leaf represents the unit numbers from that list from 5. So in this case, there was 1 unit of 59, which was the lowest. Then afterwards, there was a 64, a 67, a 68, and another 68. This is what this line shows here. This row represents 64, 67, 68, and 68. And then again, 70, 72, 74, 76, 77, etc., etc. And so this representation here, you can see how in a histogram, if we look back on the top here, I'll just change color. You can see that the histogram has this curvature, but we can't see the numbers. This stem and leaf plot, even though it's flipped to its side, you can still see the curvature, same like a histogram, but you can also see that the numbers involved as well. So it gives you a bit of an indication of what values or what data values are. Okay. Now, there are 2 important features depending on what type of mathematics you're doing, if you're doing VCAL or VCAL Numeracy, or if you're doing neural maths. In VCAL Numeracy, we use what's called the scale. And the scale just tells us the place value for each leaf. So what does that mean? This scale is saying there's a scale of 1. So that just means that each number that goes up can go up by 1. Okay, so we've got 59, you can go up by 1, and then 1 again, and then 1 again, and then 1 again, and then 1 again to 64, and then again to 67. So you can either have scales that go up by 1, they can go up by 10, they can go up by 100, they can even go the opposite way. They can go up by 0.1, they can go up by 0.001. It really just depends on what data set you have. So a good way to get a hang of the scale, once you get the hang of a stem and leaf plot, is to look at another example. Before we get to this, this is showing you that if we flip this to its side, okay, and put all the stems on the bottom and list the leaves up as vertical bars, you can see it shows the same type of information, and it's proportionally the same as a histogram. Okay, the numbers are still in there, the data values are in there, so you've got this almost extra hidden layer of values within this graph, and it's pretty neato, I like to think anyways. So this example, the next example, we're going to look at this here, and this is taken straight from your textbook, which you can find on Compass and on Office 365. A greengrocer recorded the weights of all cantaloupes sold on a particular day. Construct a stem and leaf plot for the data shown below. We also need to include a scale, and the question doesn't specify this, but we do need a scale. Okay, and you'll see the difference between this scale and the other scale. For now, how you construct your stem and leaf plot is as follows. You start off by drawing a vertical line down and a horizontal line across. The horizontal line on the left hand side is going to be smaller in comparison to the right, because we don't know how many leaves we're going to have, but we definitely know we're just going to have a single column of stems. What those leaves and stems are, we'll get to in a second. Next thing we do is we label stem and leaf. Okay, we're going to look at these values here, and we're going to try to decipher what the lowest one is. So the lowest, and we're going to try to find the highest. So the lowest looks like 0.7 is the lowest from this list. Yep, so the lowest is 0.7, and the highest is not 0.8, that's the next one. The highest is 3.9 by the looks of it. No, there's a 4.3 here. I don't think there are any 5 point anythings. Yep, the highest is 4.3. Alright, we're gonna stop. This here, this little chart or form of numerical information tells me that the stem is going to start at 0, okay, because of this 0 here, and it's going to climb its way up all the way to 4 because of this highest value here. Now, because we're dealing with decimal points, doesn't necessarily mean I'm going to put a decimal point in my stem, okay? That decimal point, that information will come later on when it comes to writing what the scale is, okay? So now we're going to just look at our zeros, okay, 0 points, and see which numbers there are. There's a 0.7 and a 0.8. So what we're going to do is we're going to put our first leaf value of 7, and then the next one, and the last one for our zeros, is our 8. And you'll notice that I've put this in order. Okay. And not in order by when I found them, but in numerical order. Okay, 7 is less than 8, so 7 goes first, and then 8. This has to be in order, okay? So your next one, we're gonna look for ones. So we have what I like to do is I like to underline my next set. So 1.1, 1.6, 1.4, 1.7, 1.8, and 1.9, and another 1.6. So we got 1, 2, 3, 4, 5, 6, 7 numbers. And then I just constructed, I comparatively look at all the numbers to see which one the smallest one is. So 1.1, and then we have a 1.4, 1.6, and then another 1.6, 1.7, 8, and then 9. Just want to double check, scan through, no more ones. No, all good. Those are my ones done. Okay, again, we've kept them in order. Alright, so a few little side notes. We've kept them in order. We haven't put commas next to the numbers. In fact, that's almost strictly prohibited in the stem and leaf world. Okay, don't put commas there. And the other final key note is to make sure that you space your numbers evenly within each stem row. Okay, so this example here, imagine if I had like 1, 2, 3, and then I had maybe 2, 4, 6, 8, 9, and then here I had 3, 5, 7. Notice that this list here is squished to the left, and then this row here for the 2s is spaced out. Okay, that is not happening. We don't want any of that. We want a nice, evenly distributed set of numbers in coordination to each stem row. Okay, all right. Next one, we're looking at our 2s. So we got a 2.5, a 2.6, a 2.5 again, another 2.5, and a 2.1. So the first one, 2.1, and then we got a 5, 5, 5, and a 6. So 3 5s and a 6. See, I'm keeping them in line with each other. The reason why we do that is just to make sure that we can see the distribution. Okay, this distribution is incorrect because this is implying that it's going to start off low and then go higher. But because there are so many numbers here, if we were to evenly distribute them out, the line would actually start right here, not here where I think it's continuing to. Okay, so this is why distribution is a very important key feature when it comes to plotting your stem and leaf graph. All right, we've got our 3s, 3.9, 3.1, 3.1, and 3.2 and 3.4. So there's 5 of them. So notice that the 2 1s. So there's 1 done, 1, and 1, and then we have a 3.2, and then we've got 3.4 and 3.9. And then our last digit is 4.3. So there is our 4.3 done. Now, a good way to check to see that you've got all the numbers is we're just going to count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20. There are 20 digits here, 20 data points here. How you know that you've done this correctly is you're just going to focus on counting the amount of leaf numbers, not the stem, but the leaf numbers, because the stem are just number representations for the single units. We need to know that the decimal units, that they're the same amount. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Ooh, would have been awkward if there wasn't 20. So we know that we've got the correct amount of numbers in, and that right there is our completed stem and leaf plot. And here we can see the distribution has the most popularity within the 1 point numbers, so 1.1, 1.4, etc., and then tailors down as it goes to the 4 numbers. So what does that actually mean? So that just means that when you go back to the context of the question, cantaloupes, when they were sold, the most common or the modal interval was this 1 point. This was the most common side in comparison to all the data sets here. There was a 4.3, yowzers, that is a very big cantaloupe, 4.3 kilograms. that can be considered as maybe like a one-off. Okay, it's still part of the data, it's still part of the cantaloupe sold within that particular day, so you still include it. But maybe you might consider this as an outlier. And we'll get to outliers later on. Maybe there's an outlier, lies outside of the common range. We don't know this for sure, we have to do a few more calculations, but again, we'll just leave that for now. The last thing we want to put in is our scale. And in this case, our scale is 0.1. And the reason why is because this set of numbers are going up by 0.1. Okay, so to get from 0.7 to 0.8, I'm going up by 0.1. To get it from 0.8 to 1.1, I can go up by 0.1, 0.1, 0.1, 0.1. Okay, we're not going up by tens, because we were going up by tens. The next set of numbers will either be 11.1 and then 21.1 if we're starting with this number here. That doesn't make sense, okay? So a scale in this case is that. Alternatively, you won't do this. If you were to do general maths, you would write a key, and it pretty much just means the same thing. And actually, I prefer the key, to be honest, because the key says that if I were to just grab one of these random stem leaf examples, say for instance the 2/1, which I've just got here, you can use any two numbers, one for leaf and one for stem, one for leaf. You would just say that 2/1 is equal to 2.1. So the reader knows, oh, when I see a slash, it's represented by a decimal point. Okay, and this is the year 11 general maths approach. Now you would just stick to the VCAL approach, which is this one here. Okay, that concludes this lesson log 5 stem and leaf plots. Go ahead and attempt question 1 and 2, which is 36.5. I will see you guys in the next video. Ta-ta.